Hello everyone, this project is about LPG gas leakage detector and rectifier for the alert system. I'm Keerthika and I'm going to explain about introduction, problem statement, objectives, functional requirements and scope of the project. So this is the outline of the project. Introduction. Let's see introduction about the LPG. Liquefied petroleum gas is the most commonly cooking fuel used throughout India. Besides being cheap and easily available, LPG serves as an ideal fuel for cooking purposes. With the increase in the number of people using this fuel, it is the need of an hour to provide some safety measures which are required to be implemented to lead an accident-free life. The major accident related to the use of LPG happens due to the leakage of gas, which is dangerous. Gas leaks can occur from the gas cylinders, which are used in almost all of the household of India. So the importance or need of the application of LPG gas leakage detector and rectifier. First is to avoid accidents. Fire accidents due to the gas leakage are avoided. It avoids the exposure of human beings to hazardous gases which affects human health. This can be applied to any setting like home, car, or gas agencies and industry. It is not specific to any particular industry. Second one is to save energy loss. Energy caused a high in leakage can cause significant loss. By gas leakage detection, energy can be saved by the amount of fuel used in the system. This is a problem statement of our project. To develop a model that detects, alerts a concerned user about the leak, and rectifies LPG gas leakage. These are the objectives. First one is to study GSM, that is Global System for Mobile Communications, for efficient communication between sensors and controllers. To study about sensors, that is MQ6 sensor used for this project and their technologies. To develop a low cost model because the proposed model and the existing models are of high cost, so we are using a low cost model for the LPG gas leakage. To develop an efficient system to alert the consumer through mobile by the location of GSM. This is a feasibility analysis, which is meant by flexible by cost and whether it's flexible for the members who are doing the project. This LPG gas detector and rectifier is practical to build technically and use conventionally. This project is feasible with low estimated cost. Use of this system will be profitable in homes, cars, or gas agencies and industries wherever gas leakage can happen because of liquefied petroleum gas. Benefits the consumers of LPG who can use it without any fear of leakage or accidents. Satisfies the requirements to stop the gas leakage, rectify it, and alert the user. This is the scope of project. Why do we use this project? Considering the recent rise in the use of LPG in developing countries due to its cheap price, less soot and low smoke, the need for an efficient system to detect the leakage in the gas and to timely correct it is important. Thus, a project is not limited to just the household where LPG gas is used, but also expanded to factories, industries, vehicles, etc. These are the functional requirements. For this project, we use a gas sensor MQ6 over the capability of detecting and correcting a gas in the air. In case of a leak, the gas supply should be immediately stopped to prevent accident, and this is done with the help of a solenoid valve drive unit. The user is also alerted through an SMS alert with the help of a GSM module. A buzzer is sounded and the LED lights up if the gas leakage starts. Mradima will explain about the non-functional requirements. Thank you.
Hello, this is Sharma, and I will be continuing this presentation of our project on the detection and correction of a leakage in an LPG gas and sending alerts to the concerned user. I will be talking about the next few topics. I will be starting with non-functional requirements. So the model that we are preparing is easy to use and will not require prior knowledge of using the model. It will require very low maintenance and only timely changing of the battery, that is the power supply, will be required. The response time of the model of the gas leak for the gas leak is very fast and hence no delay in detection and correction of the leakage, and thus accidents will be prevented. The device is portable as it uses only a battery power source instead of a plug-in power source. So now we'll be talking about the model. Our main component is an Arduino Uno microcontroller. It will be connected to the power source. We will be connecting it to the MQ6 gas sensor, the solenoid valve, the LED, GSM and buzzer, that is all the other components. So now in case of a gas leak, the MQ6 gas sensor will detect the gas leak and will send a signal to the Arduino microcontroller. After this, the LED is lighted and the buzzer is sounded. Also, the signal is sent to the GSM module with the help of which an SMS alert is sent to the concerned user. Now, after connection and alert, the signal is sent to the solenoid valve, and the solenoid valve helps in turning off the gas supply, and the leakage is stopped. So now we'll be talking about the list of hardware components, starting with gas sensor, power supply, Arduino Uno microcontroller, GSM module, buzzer, LED, bridge rectifier with capacitor filter, and normally closed solenoid valve. So the first hardware component is our gas sensor, which is an MQ6 gas sensor. The vendor is Ajax. The price is rupees 169. The specifications of this will be the working voltage is a DC voltage of 5 volts. The working current will be 150 milliamperes. And this gas sensor module is useful for gas leakage detection in home and industry. It can detect LPG, iButane, methane, alcohol, hydrogen, smoke, and so on. Based on its fast response time, measurements can be taken as soon as possible. Also, the sensitivity can be adjusted with the help of the potentiometer. The next component we'll be talking about is the power supply. So this will be used to supply power to the LPG gas leakage detector and rectifier circuit. So the model that we'll be using is an HLK PMO3. The vendor is Highlink. The price is rupees 250. And the specifications of this are that it is an ultra thin, ultra small power supply source. Although it accepts all voltage inputs and it has high efficiency, high power density. The next component that we'll be using is an Arduino Uno microcontroller. The vendor is Cloudtail India. The price is rupees 451, and the specifications are that this is a microcontroller board which is based on the Atmega 328. It has 14 digital inputs or output pins, of which 6 can be used as PWM outputs, 6 analog inputs, a 16 MHz ceramic resonator, a USB connection, a power jack, an ICSP header, and a reset button. So this will be used to connect all the components, that is the buzzer, the LED, the GSM, when the gas leakage is happening. Thank you.
Hello everyone, my name is Shreshta Burman and I am here to talk about our embedded systems project, LPG gas leakage detector and rectifier. My teammates Keerthika and Mradima have already spoken about some of the components of the project, and I am here to talk about some of the hardware and software requirements of the project. The first hardware requirement is GSM module. GSM is used for mobile communication modem. It stands for Global System for Mobile Communication. GSM, the model we are using here is A6 GSM GPRS kit module. The vendor is Greylogics and the price is around rupees 650. The description of the GSM module is that it is used to send an SMS alert to the user whenever a gas leakage is detected. The next hardware requirement is the buzzer. The model used here is 5X buzzer. The vendor is HXD. The price is rupees 99 and specification, it is 3 to 9 volt DC buzzer. Whenever a gas leakage is detected, the buzzer is turned on, so it acts as a gas leakage alarm. The next hardware is LED. The model is T10W5W automotive LED bulb. The vendor is Global Sources. The price is $0.123. It is a 5050 SMD 2 LED 12 volt DC voltage. LED stands for light emitting diode. It is a semiconductor light source. The leakage of the LPG is indicated by using the LED light. The next hardware component is the bridge rectifier with capacitor filter. The model used is GBPC 5010 diode bridge rectifier. Vendor is Magideal. The price is Rs 200. Specification: it is 50 ampere 1000 volt AC to DC. Description: it gives a rectified DC power supply for powering the various electronic basic components from available AC main supply. The next hardware requirement is normally closed solenoid valve. The model is CJV23C12A1. Vendor is SRS Tech Trader. The price is around Rs 499. It is a plastic structure. Voltage is 12 volt. Rated current is less than 110 milliampere. It has a DC resistance of 114 ohms. The solenoid valve system acts like a first aid. Automatically uses a normally closed solenoid valve for the shutting off of the gas valve before calling for help, an audible alarm to those within the environment. The software that is used is Arduino software IDE. The version is Arduino 1.8.4. The open source Arduino software IDE makes it easy to write code and upload it to the board. It runs on Windows, Mac OS X and Linux. The environment is written in Java and is based on processing and other open source software. This software can be used with any Arduino board. The references of all the hardware components are given below the slide. These are the references of the project which we have taken. Thank you.